Hi, my name is Ioannis Anifantakis. I'm a professional software engineer and an Android developer. In this video, we will talk about the manifest, the context, and the Android system. But our main focus and the main subject is the Android context, and everything we will refer to will end up helping us understand what the context is and why it is being used. So, let's start with the reasons behind this talk. So, all Android developers every day come across the Android context even in the most basic applications. Yet, because the context can be used under various circumstances for different reasons, it can be hard to absorb, resulting in lots of developers forming varying impressions around it. The outcome? Well, several developers end up just passing a context when necessary through the application or the activity objects without further thinking since their code will build and run. However, poor usage of the context in the application code can cause a few memory leaks and a few nasty application crashes. Also, ambiguity about what the context is or why it is used prevents developers from having a clear picture of the code they write and the libraries they use. Now, much of the confusion around the context begins by not realizing how closely it is related to the manifest, but also by not knowing that when looking at the context and the manifest together, they can expose much about how applications are coupled with the Android system. As a result, in this video, we will approach the manifest and the context in respect to the underlying Android architecture, so you understand why they semantically represent from an application's mechanic standpoint. And for all that, we will intentionally avoid code technicalities and stick to what the context really represents and the problems it's called to solve, because understanding should precede learning and not the other way around. Now, however, to do so, I will refer to several Android components, yet you will see that everything will be centralized around the Android context and how it binds with the Android system. So grab a cup of coffee and let's get started. So what happens when you install an application? When you install an application, the app is given its own unique Linux user ID and runs on its own instance of the Android runtime. Thus, each application is completely isolated with all its resources inaccessible to every other app. Then, when an application is run, it is restricted from constructing and managing its own components and accessing even its own resources by direct code. Indeed, it depends on requesting the Android system to do that on its behalf. Now, overall, this isolation approach assures a more secure, better structured, and lesser prone application due to leaving much of the responsibility to the operating system rather than to developer code. But if Android system is that restrictive to its apps, then that raises two issues that needs to be addressed. Firstly, the applications need a way to communicate with the Android system so they can request it to construct and provide the components and resources that are otherwise inaccessible directly by code. And secondly, the Android system should keep track of all the installed applications and their components in order to launch or provide them back to the caller when receiving a request that fits their existence. Now, to address the above problems, the context and the manifest respectively come to the rescue, and as you can see, there's an obvious correlation between them. So, we will start with the manifest. All Android developers should be aware that every Android app they build is accompanied by an Android manifest XML file. When you create an application, the Android system really knows nothing about it unless posted in the application's manifest file. Even to have the application's icon at the app drawer, you need to declare an application to be the launching activity via an implicit intent declaration using an intent filter in the manifest. Now, inside the manifest tag of the Android manifest XML, you declare package information of the application so the application can be added to the application layer of the software stack by the Android system so it can become reachable after it's being installed. Then you need to declare permissions using the permission tag for Android to know what restricted hardware and software resources should be made enabled to your app's unique user during application execution, and any custom subclass implementation of the four application components you wrote inside your application for Android to index them so it can then provide them back to the caller when an application request fits their existence. These subclasses can be submitted to the manifest through the following tags: activity for activities, service for services, provider for content providers, and receiver for broadcast receivers. Now, there is a reason we call these classes the four application components. That is because out of all the custom classes we create in our code, only subclasses of these four components can make it inside the manifest through the mentioned tags in the previous slide. But why does Android need subclasses of these four types to be declared in the manifest? Let's start with intent. When you make an explicit intent from some activity to open another activity, you never create a new activity object and pass variables to its constructor. Instead, what the explicit intent does is ask the Android system to create and launch the target activity on your behalf, and then pass a bundle of data rather than passing constructor parameters. And that is what an explicit intent really is. Now, how do intents relate to the manifest? Well, because the Android operating system has already indexed all the components during app installation thanks to the associated manifest declarations, it knows where to find the requested component in order to construct and launch it on behalf of the intent's owner. On the other hand, when you make an implicit intent, you don't really know what activity will handle your request. In this case, the Android system will check all the manifest declarations that fit the request's intent filter for every installed application to figure out what set of activities or other component types can handle your intention. So it can then launch the appropriate component that serves that intent filter. And as a side note, it should now make sense why bundles can only contain a fixed set of data types. It is because in intents, it is a operating system that will construct the components on behalf of the caller. And therefore, it is also the operating system that should also receive and forward parameters from the caller to the target component. So bundles is a mechanism to pass compressed parameters between two components with the operating system sitting in between. For Android to pack the caller's data or serialize it and reconstruct it at the target component or deserialize it, it needs to use data type it knows about or combinations of such data types. And this is the reason behind fixed data types in bundles. You can think of intents as intentions. So, intents is the Android's way to have a context, which we will discuss later, ask the operating system to construct and launch or deliver application components on behalf of the caller app, like starting activities, services, or delivering a broadcast. So, let's take a brief look at each application component and its relationship with the manifest. Activity is a single focused thing that the user can do. So activities are the application components that host your UI by inflating layouts with set content view. Now, how the manifest is related with the activities? Android is aware of all the activities that can be launched implicitly or explicitly, thanks to the registered activity entries at every manifest out there. Then services can perform long-running operations at the background. They do not provide a user interface. Once started, the service might continue running for some time, even after the user switches to another application. And how do services relate to the manifest? Android is aware of all available services through every application's manifest declaration, so it knows what background operations it can launch. Then we have content providers who manage access to a central repository of data. You can use content providers to provide data within your app or to provide data to other applications. For example, to access your phone's contacts list, you will request a content provider for that list's content to be provided back to you. And again, how do content providers relate to the manifest? Android is aware of all the content providers, so it can provide content to your app or other applications when needed, thanks to the manifest declarations. And finally, broadcast receivers are there to receive broadcasts made by some Android service or application. And again, how they relate to the manifest? Android is aware of every receiver registered to listen to a broadcast thanks to that receiver's entry at the application's manifest. So even when the application is not running, the receivers that are registered to a specific broadcast can get notified. Now, as a side note, I need to mention that it's not obligatory to declare receivers in the manifest. Um, the applications can receive broadcasts in two ways: by manifest declared receivers using the receiver tag at the manifest, where the receiver will always get notified, or by dynamically registered receivers at runtime, where the register will listen to broadcasts during the time you have asked it to listen. Okay, so these four application components, when declared at the manifest, they let the Android operating system know they are there, so it can take action when some request by your app or some other application fits their existence explicitly or implicitly. Now, for the manifest summary. The manifest notifies the Android system of the application's own existence, any permissions needed, and the components of your app so the Android can launch or access them on your behalf. Now, this approach yields a potentially richer application experience due to other applications components becoming available to your app through their manifest declarations, either by fitting your implicit intents intent filter or by providing you the content through their content providers. So here we have a way richer experience thanks to the manifest. Before talking about the context which follows next, we should make clear that not all manifest entries refer to context class descendants. Context manifest entries are context class descendant objects that perform UI or background operations. They are directly constructed and launched by the operating system, and because of that, they have a life cycle whose state is administered by the operating system. Those manifest components are application, activity, and service. You can see the class hierarchy for anything that inherits from the context class in light blue color in the graph. On the other hand, non-context manifest entries are objects that employ a provided context to get a standardized job done. They are not context class descendants themselves, and as such, they have no life cycle nor state exposed to the application. These manifest components are broadcast receivers and content providers. And as you can see from the graph, these are highlighted in green and are not inheriting from the context class. More specifically, for the non-context manifest components, let's look at some notes from the Android developers website. for content providers, when you want to access data in a content provider, you use the content resolver object in your application's context to communicate with the provider as a client. That is, with content providers, we use the application context as a communication vehicle to be provided with the desired content. So you see, they are not context class descendants, but they consume a context. Now, for broadcast receivers, the broadcast receiver class is the base class for code that receives and handles broadcast intents sent by context.send broadcasts with a path intent. That is, from from a broadcast which was delivered to the Android system via a context by your application, another application, or a system service, the Android will notify all the receivers registered to listen to that broadcast. And for that, you also consume a context. And so receivers are not context subclasses, but they use a context to get the job done. Now you got a better grasp of the manifest. You realize with so much burden falling to the Android system, your app needs a handle to the Android itself to pass its requests and obtain content. That handle comes in the form of an Android context. But before anything, let's look at the official context definition by Google, which by the end of this talk should make perfect sense. So the context is an interface to global information about an application environment, which means that because the context is your application's handle to the Android system, it is also a window to observing information regarding the device environment your application is running at, like if your device is using a dark or light theme, if the device is in landscape or portrait mode, but also seamless integrations to global setups like automatically applying the correct font sizes to a custom text view by combining the device's global font size setting with your custom SP value so it can come up with a final font size to be rendered in the text view during layout inflation and more. This is an abstract class whose implementation is provided by the Android system. Here are two things to note from this sentence. The first thing is that being an abstract class means you will never find any direct context objects, but you will find objects that inherit from context and get access to the context through these objects such as activities which are context objects because they inherit from context. Now, the second part, which we will analyze a bit deeper, is that the implementation of this class is provided by the Android system, which means a few things that we will see together. Now, the first is that since the context is implemented by the operating system, you can use it to talk with the operating system, and thus it makes sense when we said earlier that it is a handle to the Android system. But for the implementation to come from the operating system, context objects should be constructed directly by the operating system with mechanisms such as intents rather than using classic constructors. So it makes sense now why we use intent to construct context descendant classes. And finally, if the implementation of the context is provided by the Android system, then it is the Android system that will manage the lifecycle of such objects. And thus, those objects gain state that is exposed to listener events like on start, on pause, on stop, on create, and so on. It allows access to application-specific resources and classes. Yes, resources too are provided by the Android system through the context and not by direct application code. Android provides resources by a key-value based mechanism that uses a context to request a resource's value. This is not only secure as you don't get file system access to the REST folder, but it's also smart as the Android system can even decide between returning different variations of a resource's value based on global settings. For example, based on the device's language preference, Android can return the appropriate value of a string resource kept in multiple languages. And the final chunk, app calls for application level operations such as launching activities, broadcasting and receiving intents, and so on. This final part says that the context can also be used actively as the way to make app calls to the Android system to launch or provide components declared in the manifest. It is the place where the manifest and the context actually meet, with the context requesting actions on components that only the Android system can fulfill by looking up the manifest entries so it can fetch them or launch them as requested. So the Android context binds your app with the Android system for anything that cannot be done or retrieved without going through the Android system. So where can I find the context? Since the activity, service, and application classes are all context-dependent classes, you can pass instances of these classes as your actual context in method calls. But since the above classes have different life cycles, passing, for example, an activities context as the Android handle to something that is related to the entire app, your activity wouldn't ever be allowed to be garbage collected as you hold a reference to it, which translates to a memory leak. So why not just always use the application context instead? I mean, since all we need is a handle to the Android, why not use a handle that lives for as long as the application lives and forget about memory leaks forever? Well, the reason behind having different life cycle context is this. Okay, so firstly, activity inherits from context theme wrapper, while the service and the application do not. You see that theme word in that class? So you see that as application context is not UI related, it cannot be used to inflate layouts, start activities, or display dialogues. If you attempt to affect the UI using a context that is not UI related, you will only crash your application. A classic example is trying to display a message from inside the service. Also, depending on what context we pass, we get access to different information about the application's environment, like with two different UI context objects that belong to the same application, but they use a different theme. And now for other tasks, like for a singleton object that will be used throughout the application and requires a context like access to a database, you will use application context to avoid memory leaks because you will hold the same database reference throughout the application's life. So, depending on what you do, you will have to choose a different context for different cases. Okay, so whenever you try to do something that needs the Android OS to act as an intermediary in order to fetch global information, resources, perform tasks, or provide content that cannot be handled directly by your code, you will have some method call that requires passing a context. Now, the roles of context inside method calls. Passing a context in method calls in Android is very frequent. However, the fact that you may pass a context for completely different reasons is a major source of confusion for developers, as the Android's context role is not that clear. And as we saw, on the context definition because the context is the bridge between our app and the Android system. It serves multiple roles. So let's see these roles pretty fast. So when you include a context in a method call, the context might play one of the following three roles. Passive role, to ask the operating system for some information. For example, what's the value of a resource? Active role, to ask the operating system to perform some action on your behalf. For example, launching a component through an intent or inflate some layout or display a message and so on. And binding role, which is to connect your application to a distant entity managed by the operating system. For example, opening a connection to an SQLite database, where that binding will be used in both active and passive roles to read and update data in the database. In such cases, you almost always use an application context as the binding should exist throughout the lifetime of the entire application. Now, in any case, a context is always the operating system intermediary that stands between your code and the Android system, delivering requests in order for some information to be retrieved or for some action to take place. So the next time you use a context in a method call, you will know it is the vehicle that will reach the operating system and ask it to execute or retrieve your method's request. Now, on top of the three roles of context as a method parameter, there is another role that represents the context as an object instance of a custom class that inherits from the context class. A custom activity or a service you wrote or your very own application are context descendants. And when constructed and launched by the Android operating system, they obtain a life cycle. As you see from the diagram of the Android platform architecture or otherwise the Android software stack, your application is put inside the application layer together with all its application components. So the component role is the role that represents a custom launchable component. These custom launchable components belong to the application layer of the software stack, but they extend or use classes defined in the application framework. And as such, they serve as a bridge between the application layer and the application framework, and thus between your application and the Android system. When these context descendant components are created and launched by the Android operating system with mechanisms like intents rather than directly through constructors, they are given a lifecycle managed by the operating system. For example, for a class that extends the activity class, if you try to instantiate it by normal means like myActivity object equals new myActivity, the onCreate method will not be called. Only if you start the activity with an intent will the method be called. So the role of the context as an object is to bridge its subclass launchable component like an activity with the Android system so the Android system can provide and update the lifecycle status of that component. So summary about context. The context is an abstract class provided by Android, and as such, its job is to bridge your application code with the Android system. Through classes that inherit from context, your application gains the ability to access resources and functionalities reachable only by the operating system. When objects of such classes get instantiated by the operating system through OS control instantiation mechanisms like intents, they become administered by the operating system and as such they obtain a lifecycle. For anything else, passing a context as a parameter in method calls allows this method to use that context as a channel of communication with the operating system in order to reach the OS and ask it to perform some action or return some resource. To visualize the concept of the Android context and the manifest in action, an old calling center switchboard sounds like a good analogy. The base is the application framework where all the wires that connect every application component with the Android system emerge from. Then, each application, through its manifest declarations, exposes plug holes for every declared component to the Android system. So it can when constructed, it can put a context wire to manage them. And finally, each wire is the constructed launchable component, which binds that application component with the Android system. So the manifest adds applications to the application layer of the software stack and creates plug holes for each application and its components. When the Android system constructs a component that inherits from context, a context wire automatically plugs into the newly constructed component's plug hole so the OS can link to it and manage it. You can assume that during component destruction, each wire gets unplugged, while when other component gets constructed, a new wire emerges and connects to the corresponding manifest declared plug hole. Now you know why the context exists, you will appreciate the difference between local and instrumented tests. In a nutshell, unit tests do not require any interaction with the Android operating system and run your test code directly at the Java Virtual Machine or JVM. While the integration tests assume the involvement of the Android operating system with your code at some point, and thus they need to run on an emulator or a real device, making them significantly slower and cumbersome than local unit tests. So, instrumented tests are usually required when you need to perform something that involves heavily the operating system and thus obviously involves the context. Or if you are testing custom components like testing directly an activity, you obviously need to run an instrumented test on an emulator or on a real device. Now, as a side note, for simple cases where you just need a context that doesn't require deep involvement of the OS, like just bringing using it to get a string resource, for example, you can mock that and you can avoid using it. So you can get away with using local tests rather than instrumented tests, but that's out of the scope of this video. With all that in mind, if with design patterns like the MVVM, which is endorsed by Google, you can keep all the business logic in the view model and then keep that logic away from the UI and from the data layers by providing mock data in repositories with sample data. Then your business logic should be clear of context items. So you can test your view models with local rather than by instrumented tests, leading to faster testing and much clearer and easier to debug code. But to isolate the business logic, it is necessary to understand when your code involves the Android OS and when it doesn't. So, understanding how your apps are coupled with the Android system can help you acknowledge even further the reasons behind choosing design patterns such as the MVVM that promote the separation of concerns and maybe even adjust the way you approach and write code. So, closing with the significance of context. As we saw from the testing section of this video, if the context didn't exist, every test could be run as a unit test, and thus the Android would only be libraries built on top of the JVM. So if the context didn't exist at all, you wouldn't have an Android app. You would have a Java application or a Kotlin application that would simply require some additional libraries that would work at any operating system with a Java runtime environment installed. So with all that, we can argue that it is due to the context your app is an Android application. Thank you for joining. Have a nice day. I hope this talk was helpful. See ya.